Hi there everybody, we are looking at circle theorems today. I'm going to run through 3 different circle theorems. There is another lesson on this about the other 3 circle theorems, and there is obviously, I think there are a bunch of other ones that we're talking about the circle theorem proofs. So if you're not sure about any of this, please take some time and go to have a look at the other videos and making sure you're taking some decent notes on these. Alright, so it's about spotting them and recognising them, and this obviously appear in the higher paper of a GCSE exam. So let's look at all these different ones bit by bit by bit, but please definitely look at the other videos as well. So the angles at the centre, all right, so what we've got is essentially you've got a centre of a circle, all right, and 2 radiuses that kind of come off from there, and then from that you've got another 2 lines that form an angle at the circumference essentially, all right. So what that does, if you've got 2 radiuses and then you draw a line from those 2 edges that go to another part of the circle, this angle here is going to be half this one. All right, so that's the rule. All right, so if 2 angles are both created from the same points, one which goes to the centre and the other goes to the circumference. So what we're saying is you get 2 points. One goes to the circumference, one goes to the circumference, and the other goes to the centre. All right, the angle at the centre will be double the angle at circumference. All right, so that means A is half of B, or B is 2 lots of A. All right, so in terms of an example of looking at that one, so find D, what we're saying is I've got 2 points, so there and there, 2 points there and there. One goes to the centre and the other one goes to the circumference, and therefore, what happened there? This one here is going to be double that one. So so they're going to be 84. All right, there you go. What about this one? Not as pretty in terms of looking at it, but what you've got is still got 2 points there and there. They go to the centre and then they go to the circumference. It's just what's happened is it's moved round. So what you're used to seeing is it up here, but of course they've kind of moved it to the side. All right, so this is what you've got to be very, very careful of in terms of what examiners might do. They might see if you actually understand that very, very clearly. I've got 2 points, that goes to the centre and that goes to the centre, and then this one goes to the circumference. All right, so this one over here is going to be half this one, right? So it's going to be 45 degrees. All right, so be very, very careful, and you'll see why I talked about this one a little bit in a minute in terms of where the confusion might lie. But that is definitely 2 to the centre and then 1 to the circumference. Okay. Second rule, cyclic quadrilaterals. All right, so what you've got is a quadrilateral which fits exactly within a circle, and all your corners of your quadrilateral must touch the edges. All right, so must touch the circumference, I should say. All right, for this to kind of apply, and essentially it is the idea of the 2 opposites of a cyclic quadrilateral are equals 180. So that means A plus B is 180 degrees, and that would be the same for these 2 here. So that one plus that one must be 180 as well. All right, and that is a circle theorem proof. All right, so which I'll talk to further down the line to show you how that works. But essentially, yep, that plus that is 180 degrees. So that's a circle theorem. So here we go, and here's an example. All right, so I've got four corners of a shape touching the edges of a circumference. So these 2 added together, it'll use 180. So 180 take 134 is going to give you 46. So that's 46. Over here, same thing. I've got this one, this one, this one, and this one, all touching the circumference, and I know that these 2 opposites must add up to 180. So that plus that. So this is more about algebra and shapes, isn't it? So there is no lesson on algebra and shapes, so please look at this one. But certainly those 2 added together equals 6a, which is equal to 180. All right, so I can write that out. So 2a plus 4a equals 180. And then, of course, I can solve it. So divide both sides by 6, and then you've got 30. So A is 30. All right. So they're just trying to introduce some additional ideas into the kind of circle theorems as well. All right. Right. So last one in this one. I said there are 3 others on a different lesson, so please look at those. The angles in a semicircle. All right. So if you've got a diameter that crosses all the way across, then what you've got here is a right angle at the top. All right, you can see it already kind of written in there. So if you've got diameter, so straight line all the way across, then you've got a diameter. Now, arguably, these are 2 points here that go to the centre, and then the other 2 go to the circumference. So arguably, this actually arises from the first one we did right at the beginning, because this angle here is 180, and of course that's half it, which is why it works. All right, so we've got 2 radiuses, which ultimately form a straight line in this case, so you've got 180 degrees, and therefore that angle there is going to be 90 degrees. All right, so if you've got a diameter, here we go, diameter, and then you've got that one over there, then that angle there is 90 degrees because it's formed in a semicircle. All right, and then you may have something looking like this, which again is trying to get you to use the idea of not necessarily going straight to this one, but thinking, well, this one here is 90 degrees, and then I've got a triangle. So it's now thinking about angles in a triangle that was 180. So again, you can start to see that other types of maths are starting to be introduced to this. So this one over here is 90 degrees. So 180 take away these 2, it's going to leave you with this one. So there you go, which is going to give you 26 degrees. All right. All right, so that's first half of circle theorems. If you obviously need to practice on those 3 things, then please visit maths-school.co.uk for additional practice. But I would also recommend you have a look at the other circle theorems in the other lesson. Thanks for listening.